Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. If you have any questions throughout the session, if you're watching on Zoom, just use the Zoom controls wherever they are on your screen. You should see a little button that says Q&A. Click on that, type in your question, hit submit, and I'll get to those at the end. If you're watching live on YouTube, just use the live chat function wherever it happens to be on your screen. Or if you're watching after the fact on YouTube, just feel free to leave a comment. We'll get to those later. Also, if you're watching on YouTube, make sure you like, subscribe, and all that good stuff. So my name is Jason Gabrinas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last 10 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple of years as a diagnostic sales rep at Snap-on. So I had about 30 different franchisees I work with, as well as the shops that they service, in order to help everyone get the most out of their diagnostic needs. Then before that, it was 8 years at Subaru. So worked in a dealership, and over time, I guess, became the default diag guy in the shops. I always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher cars that would come into my bin. And before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is the power of OBD2 information, and this is a two-part series. We're going to kind of split it in half here. So part one is this week, part two will be next week. If you watch them both back to back, guess what? You get the whole, all the information. So this week we're going to cover kind of what is OBD2, where did it come from, how did it develop, the history and all that. And then we'll go through the first half of it, first four modes 1 through 4, plus readiness monitors, a couple other things as well. And then next week will be modes 5 through 10, and we'll talk through that. So OBD2 information. In the beginning, we go way back to the 80s. The very first diagnostic tool out there for technicians was going to be this humble paper clip. You take the paper clip, you undo it, and you short out two pins next to each other, and you count how many times that light flashes on the dash. And hopefully you count it correctly, because otherwise you might be diagnosing the wrong code. But if it blinks like 2 times and then pauses and then blinks 3 times, then you know that's a code 23. For example, back then it was all factory codes. There was really no standardization back then. And over time, obviously, they saw they needed a need for that. Now, GM, for their part, because they were one of the first ones to put this out, we'll see that on the next slide. They actually had a tool that they put out. You can still buy it today. It's an OTC tool, and it's like $17, I think. But it was just a little thing that went into the 2 pins and shorted it out. I'd probably rather use the paper clip. $17 for a little tool to short out 2 pins. I don't know, but hey, you can look them up on Amazon, and they're there. So a little history, as we said, 1981, GM introduced the ALDL connector. So ALDL stands for Assembly Line Diagnostic Connector, and that's this guy down here on the bottom. And this is the pinout for that. So different data links for different things. Diagnostic terminal A and B. So really, you just short those 2 out, and that's where you get your flashing light, right? So that was one of the very first OBD1, I guess, connectors. 1988, CARB, which is the California Air Resources Board, they have a lot of say in what goes on with emission systems on cars, for better or for worse, but they required some OBD capability on all 1988 and newer vehicles. So if they were sold in North America, or at least the United States, I'm not sure how Canada went with that, but 88 and newer, anything sold in the States had to have some sort of diagnostic capability. 1996, they decided, well, there's all this smorgasbord of different connectors and different protocols and things like that. So in 96, they decided that OBD2 was be mandatory on all vehicles in the US. And that was SAE, the Society of Automotive Engineers, came up with that standard and made it mandatory in 1996 in the US. Over in Europe, in gasoline engines anyways, EOBD, which is Enhanced Onboard Diagnostics, was mandatory starting in 2001 over there. And then diesel vehicles were added as mandatory in 2004. And then as far as over in the US, CAN bus communication was required starting in 2008. So if you had diagnostics on your vehicle in 2008, it had to use CAN bus, at least for the main engine, transmission, and so on. So as I said, back in the early days, it was kind of the Wild West here. We had all these different connectors that you would have. You had, let's see, this Toyota connector. I think that's a Subaru connector, actually. Honda's in there, BMW's in there, Chrysler's in there, Ford's in there. So a lot of different manufacturers using a lot of different types pins there. That's the Mercedes, that's the BMW. So there's different things on different pins, and that's how we communicate, right? But in order to communicate with all these vehicles, you needed all sorts of connectors, right? So we had all these different various connectors. There's a one for the BMW, there's a one for the Mercedes. There's a couple multi pins as well. So if I had one that wasn't really a popular one, it would tell you where to hook up each wire to get to where you needed to go. Plus they had, all the other major manufacturers. They did have some kind of weird ones too, like Mitsubishi here. We had to actually use OBD2 and OBD1. It was kind of like an OBD1.5 going forward. That was like early 90s, 90, 91, when they had those DSM vehicles like the Eagle Talons and the Mitsubishi Eclipses, things like that, where they're all kind of the same car, but they were under different brands. You would have to use that weird connector there for that. And now all of these still would work today even. So if I have a 1985 something or other coming to my bay, I can still hook up to it as long as I have the right connector. And then there's a little adapter here that we use. You got 15 pin on one side, and then your standard OBD2 connector on the other side. So you hook up your Snap-on scan tool to the OBD2 side. Then you pick whatever adapter you needed. You plug it in there, make sure it's powered up because it does need power. There's little power ports on the sides. Once it was powered up, however, though, you could go in and you can scan it just like with a Solus Plus, Zeus Plus, whatever. All the tools work all the way back to 1980, 81. So that's helpful. So if you have any of these connectors from way back in the day, because I know that people have probably still even have their own red brick. Some of you out there might even still have it. The connectors that came with that would still work today. And actually, you could still use the red brick on those cars nowadays too. And some people do, because they just feel, maybe it's a little faster. Maybe that could be the case because it wasn't all that complicated back then. So when 96 rolled around, we came as an industry, they came out with the data link connector here. It looks just like this. And the nice thing about it is it's standardized. It needs to be within a certain range of the steering wheel. It needs to be on the driver's side of the car, and so on and so forth. Now there were some, especially early on in the time. I know Honda hit it somewhere in the console. There's another one you had to it was near the ashtray, behind the ashtray. Remember ashtrays in cars? So back then, they could be in weird spots. Nowadays, they're fairly consistent. It's usually within a 1.5 foot area underneath the steering wheel. It's usually either on the left-hand side of the kick panel or right underneath the steering wheel, somewhere in there. Consistency was key though. So if we look at this pinout, this is a standard data link connector on any vehicle that has OBD2 is going to use this. So pin 16 is always power, battery positive. So if I don't have power there, then it's going to be hard to diagnose because that's the fuse for that. But we have pin 1 is used for low speed CAN, pin 2's J1850, pin 4 and 5 are always ground, pin 6 and 14 are always CAN bus, at least the main CAN bus. K-line, if you ever heard of that, that'll be on pin 7. Pin 15 is the keyword L-line. And then if we have pulse width modulated, we got a plus and minus on the J1850. All the other pins are available to do whatever else on the vehicle. And some manufacturers do use most of the pins now on there. I know GM, they just take up most of the pins on some of their newer vehicles. Now, there also was a place kind of in the middle there, late 90s, early 2000s, especially on European vehicles, because it wasn't mandatory over there yet, where you would get both. So if let's say a BMW or Mercedes, very good examples of those, like say an 01 Mercedes or something like that, it would have a 16-pin connector under the dash, and it would also have the 38-pin connector under the hood. And depending on what information you needed, you would have to connect to whichever connector there was particularly. So you may have heard me speak about a vehicle's computer many times like a house, right? So it's got a front door and a back. Coming in the front door is going to be all my inputs. So my coolant temp sensor, my NOx sensor, my oxygen sensor, all those inputs go in. Then the computer processes it, and then it sends that data out the back door to the scan tool. Now, what I don't talk about as often with that is inside that computer, there's also two rooms if we're still using that house analogy, right? So we have an OEM VIN specific side, which is going to be where you would go if you click on scanner. That's going to be the OEM side. There's also the OBD generic side of the PCM, and that is going to be the same on every single vehicle, pretty much the same. We'll talk about some differences as we go through here. But there's two different ways that it's going to process that data. This is up to the OEM, however it processes it, and it can be different. The OBD generic needs to be the same. No matter what across the board, it needs to give the same data, the same instructions, and so on. And you'd access that side through OBD Direct. You can also access it through the scanner side. There's a way we can kind of break that wall, put a little window through that wall, and we can get on both sides at the same time. I'll talk more about that when we get later on in the presentation. We go live on the vehicle. But just be aware, there can be times where you will have a different number of codes. You could have 5 codes on this side, 3 codes on this side, or 3 codes on this side, no codes on this side. It's going to vary depending on whatever the threshold the manufacturer decided to set in order to set a code versus what the federal emission or California emission standard, I suppose, is on the vehicle as well. So they will process them differently. You can find different numbers of codes. You can find different codes entirely in there. So just be aware that's not a scan tool problem. That's just how the manufacturer set up their computer issue. And I'm pretty sure I have some examples of this as we go on throughout the presentation. But just know there's 2 different sides, and that's why we're focusing on the OBD2 side, because we usually focus on that OEM VIN specific side, but there are differences in between. So in order to find that information, like I said, to get into that OBD generic information, we're going to want to use the OBD Direct icon on our tool, however you use it. If it's a Snap-on tool, it's going to say OBD Direct. Other manufacturers, it can be different ways, but all scan tools need to be able, at least in the States, need to be able to get into this side. Now you see we got OBD Diagnose, we got an OBD Health Check, which is kind of like a code scan, and then we have the OBD Training mode. So if you have a Snap-on tool, you can go into that OBD training mode without having to connect to a vehicle, and you can go in and actually just kind of read through it, look through OBD2, and see what the deal is. But in this case, we're going to go to OBD Diagnose. We have Start Communication, Connector Information, and Manual Protocol. So in order to actually communicate with the vehicle, we're going to go to Start Communication. And then you'll see the landing page. Now, depending on the year of the vehicle, you may see some different things here. Some of the modes may be different. Some of the modes may be missing. You may have multiple versions of a couple of these modes, and we'll get through that as we go through the between this week and next week. We'll talk about some of those differences and some of those exceptions there. Like for example, some of your newer cars are not going to list mode 5 because they kind of roll them up. Mode 5 and mode 6. That's next week. We're going to talk about that. Some older OBD2 vehicles will not have mode 10 because that didn't come into play until like 2011, I believe is when it was. And then some of your mode 9s may be different too. You'll actually see a difference when I go live on the tool as well. But if we're going to just go through this what's displaying on the screen here, first one's going to be readiness monitor. Now in readiness monitors, this is going to give you what monitors have completed either since the code was cleared, or what monitors have completed this drive cycle. So depending on where you are in your diagnosis and what you want to see, you can go in there. So monitors complete since the DTC is cleared. And you can see here is whether or not it's complete or whether or not it's supported. This is just on some demo data here, but you can see test complete or not supported at all. So this will allow you to go in, do a real quick check, say, hey, is this thing ready to pass an emissions test, for example? You do a plug and play emissions test, you're probably going to need that. You're going to have all but maybe one monitor, depends on the state, but it's usually all but one monitor completed on that. So you'd have to have all but one of those say test complete or not supported. Mill status is pretty self-explanatory. It's going to tell you whether or not the light is on. But here's one thing that's exclusive to Snap-on that I think is pretty useful, especially if you're kind of learning or relearning or trying to remember. things about OBD2, maybe you don't use it all the time. So there actually is a troubleshooter in here. So engine troubleshooter. And you'll see we have code tips, parameter descriptions, which is very helpful, guidelines and procedures, and a general help section. So if I were to go into code tips and I wanted to look up information on a code, whatever it happens to be, is it a B code? Is it a C code? Is it a P code? If you want to learn what all those mean, if you look back a couple weeks on the channel, we talked about code basics and we talked through all that. But you would just select your code and it would give you a description of that code. Also parameter descriptions, like I said, very, very helpful with that on the parameter descriptions. So we got, say, whatever I wanted to see, say like a voltage or something like that. So I picked oxygen sensor voltage bank 1. Expected reading will be engine cold, 0.45 volts and no switching. Engine hot and closed loop, 0.2 to 0.8 volts switching once per second. Read the data stream in conjunction with fuel trim for a further indication of history. Check mode 10 or data 10 airflow rate. Mass airflow sensor is reading faulty. Could command that the ECU leads the mixture off. It's going to give you a lot of useful information as to what you should be seeing in that data parameter. You can use that for your generic side. You can also use that for the OEM side to just see what good's supposed to be. Next one's guidelines and procedures. So you're going to see diagnostic services introduction will kind of give you an overview. Workflows, field recommended general mode information workflow. So you can just go in there and say, okay, what should I check in what order? And then it also gives you each of the modes, or in this case, they call them services of OBD2. Goes from mode 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 0A is mode 10. Now I get questions on this. What's the $sign? Does that mean I need to pay for it? No, it's just computer language. They just put that $sign character in there for, I'm not 100% sure why, but just it's a computer thing. And then goes from 09 to 0A because we're doing base 16. Computer language is base 16. So it would be, if I went from 9, the 10th digit would actually be A because it goes 0 through 9 and then A through F. That gives me 16 characters that I can use in computer language. So 9, so it goes 08, 09, 0A would be 10. So just know that there is no actual 10 in there. It's always a leading 0, so to be A. If they added a mode 11 somewhere down the road, it would be 0B. Right, so it just goes on up on that base 16. And then we have help. So if I need generalized help in here, 5-digit OBD2 code information, readiness monitor information to generic drive cycle, not vehicle specific, because there are vehicle specific drive cycles too, and abbreviations used. So let's look at the different modes. Like I said, we're going to go through the first 4 tonight, and then next week we'll go through the other 5. So OBD2 modes. Mode 1 is going to provide access to diagnostic data such as inputs, outputs, and status. This is going to be your data stream. All values are going to be current values and no substitute values are allowed. So this can be helpful if I'm on a vehicle that has some sort of data substitution that might be part of the logic. You can go in there and you can see here's actually what's happening. The computer's not going to lie to me. It's just going to tell me here's what's going on. This can also be referred to as serial data. You may have heard it called. So we would simply just go into mode 1, display the current data, and then it'll give us our data stream like we would be used to anywhere else in the vehicle. But just know that there's no substitute allowed in here, so you do not see that substitute data. Mode 2 is going to provide access to freeze frame data. So what freeze frame is that mode 1 data, the data stream, from the time of the fault. Once again, all data has to be actual values. No substitute values are allowed. So this might help you a little bit more than just looking at the OEM data. Freeze frame data can also be used to duplicate vehicle conditions for diagnosis. So it gives you, here's what happened exactly when the fault occurred. Was it cold? Was it hot? Was it driving for an hour? Was it driving for 5 minutes? What was the throttle? What was the load on the engine? What do I see here? That helps you as a technician go and duplicate the customer's issue. So if it happened when it was hot after driving it for half an hour, then you're going to have to drive the vehicle for half an hour when it's hot under those general conditions to see if you can duplicate the problem, right? And I love that too. You get the ones where you get the waiters come in and the car's hot, and then you go to the freeze frame and it's cold. I'm sorry, you got to leave it overnight. We got to wait till the car's cold overnight, and that usually doesn't go well, but that's what you need to do. So you'd go into mode 2, freeze frame, and then once again you would see that here's what happened at the time the last code set. There it is. Then we have mode 3, and that's going to be your codes, right? So it's going to be emissions related DTCs, emissions related only. So it's not going to be body control modules or chassis or anything like that. You're going to see emissions related DTCs only. So it's going to identify the faults using specific criteria. It could be signal or component short to ground, signal or component short to battery power, or no signal or a component open circuits. It's going to give you those codes generalized in that way. Go into mode 3. And you'll see in this case, we got 1, 2, 3, 4, 5 different codes listed. I think this is on the demo vehicle, but you'll see, intake air temperature, sensor 1, circuit bank 1, master volume, circuit range of performance, circuit low, circuit intermittent. You'll get those sort of descriptions. And by the way, remember how I talked about the two sides? Manufacturers can have different descriptions of codes versus OBD2. So that happens too. But the codes being the same would be the same. Just might have a different description. Then mode 4 is going to be your last step, kind of. So that's going to be your clearing emissions related diagnostic data. So not only is it's going to clear a lot of things. So just be aware, if you do this, it's going to clear out all the information. So all the codes on the OBD2 side anyways. It's going to clear all the freeze frame data, all the oxygen sensor monitoring results, all the readiness monitors, and all the onboard test results. So if you go through and clear this and then expect the vehicle to pass inspection like in an hour, probably not going to happen because you got to go through a drive section. Also note permanent codes, which we're going to talk about next week more, but permanent codes are not cleared in that case. So permanent codes are mode 10, and those are codes that have been cleared in the system, but then they flip over to these permanent codes, and they're going to stay there until the computer either passes the code test, so it goes through the test to run the code, and it passes, or 400 days, whichever comes first. So permanent codes can be helpful. Like I said, we'll talk more about it next week, but it can be helpful if the customer disconnected the battery to get the engine light off. If they went somewhere and they had their buddy clear the codes or something like that, you can see what codes were there, and is it still a problem with the vehicle? So mode 4, you go in there, it says clear diagnostic data, it says all emissions related diagnostic information, MIL, diagnostic trouble codes, freeze frame, etc. Okay. So let's look at the tool. I have it connected over here to my little Chrysler scanner demo board, and we're just going to walk through a few of those things that we talked about. So I'm going to go into OBD diagnose. Yes, I'm scanning a real vehicle. Start communication, manual protocol. If you know what protocol you want the vehicle uses and you want to use, that can be helpful on not necessarily a car. If maybe it has an OBD2 port, or you know what pins are what, you might be able to hook up the things that are not cars. I know I had a boat that a customer had that had a BMW 3-liter in it. And wasn't necessarily a car motor, but I was still able to go in and get data. If you find the right pins for the diagnostics, you can go in, manually select your protocol, and you can go in, and sometimes you can get data. It doesn't happen all the time, but in this case, it just did. And I thought that was kind of cool. There's also connector information in here. So if I need to find the connector on a vehicle, like, I don't know, let's say Lamborghini. It's on the left side in the center console. All right, so that might not necessarily be a standard location. It's in the left side in the center console. And then it also asks, do I want to start an OBD2 session with the vehicle? You can say yes or just no. I'm going to back up. Things like, random vehicles like a Caterham. I've never even heard of a Caterham. A Dunkervort, Morgan, Opels for over in Europe, Peugeot, SsangYong over in China, right? So we have all these different manufacturers here. It's not everything, and it's not an exhaustive list, especially if it's a vehicle that's fairly standardized at this point, like Subaru. Let's see what it says about Adjusti, right? So Adjusti was in the driver's door side steering column lower dashboard. There was other Subarus that, was in like the kick panel. Like an XT, if I recall, was like in the lower kick panel. You had to find the yellow connector, right? So it's not an exhaustive list, but it could help you in some of those weird off-market cars that you don't necessarily see every day. And then we have start communication here, which is going to start the communication of the vehicle. What it's going to do is it's going to cycle through miscellaneous protocols. And whenever it finds one that it's able to communicate with the vehicle, then it will. So in this case, it's my demo vehicle. We have one detected ECU. It's on the CAN bus protocol. And then we have the VIN there as well. Hit continue. And then you'll see that this screen looks different than the previous screens we were looking at in the slides. It has mode 10. It has 3 selections for mode 9 instead of 2, which we had in the other one. And there's no mode 5. Mode 5, like I said, rolls into mode 6 on a lot of newer ones. So every vehicle, even though it's a standard, may be a little bit different depending on the year. Because they made changes to OBD2 throughout the years. And I think though that's where some of them are going to show up. So not every vehicle is going to be 100% the same. It's going to be close, but it's not going to be 100% the same. So let's go to monitors first. Now it's going to pull up your readiness monitors and what tests are done, misfire test complete or not complete, whatever. You can actually print this out. You can save this to have that as a record. If I go back, troubleshooter, I did want to talk about a couple different things in this troubleshooter, like the code tips. So let's say I wanted to take a look at a P0 something or other. And then we have P00, P01, P02. How about P03? Ignition system misfire. So if I wanted to go into your P0303, that's pretty common, right? Sorting the engine control module when a regular combustion event occurs. ECM is programmed to expect a predictable reduction in crankshaft speed during a compression stroke, etc. You can read through that if you want. Possible causes is going to give you that down here. Just going to give you generalized information. Let's pick a different one, like a 353. That's ignition coil C, primary control circuit are open. 03A1, cylinder 2 pressure sensor circuit low. So there's a pressure sensor in the vehicle. That's that code there. So you'll see it gives you a full list of every possible code that could happen. And notice how when we get down here, we get into these hexadecimal or base 16 type codes, right? B03. And then that'd be, 15, right? Because it goes up to F for 16, 15. So there's obviously all these codes aren't going to show up on a car, but they could show up on a car somewhere, the same car, they're not all possible, but on a car somewhere out there, it's a possible code that could happen. So it's going to give you links and just show you information on that. Parameter descriptions, let's say coolant temp sensor. This must give us some data at the same time now. So it's going to give you the different, should be similar to outside temperature, between 10 to 20 degrees Celsius, amount of fuel injection, et cetera, et cetera. I'm not going to read through all these. Like I said, take a while, but fuel trims, engine run with mill active, relative throttle position, calculated load value. What do these all mean? I can go in here and it'll tell me what good should be and what it's going to look like. Guidelines and procedures, like a workflow, right? So carefully study the vehicle, verify the customer complaint, connect the scan tool, check for codes first, then check freeze frame, etc. It just gives you a good workflow to work through and then clear it and so on. And then it gives you your different mode descriptions. So let's see, mode 4, mode 3. Mode 3 displays all stored emissions related DTCs. It identifies the signal fault or sensor fault using specific criteria. All right, so it'll just tell you if you have any questions about any of that stuff, it's on the tool in the troubleshoot. All right. And then like things like freeze frame, right? We talked about that. It's going to be on whatever the latest code is. It's going to give you the freeze frame data. All right, so we can see that. Now here's the code P1404, and then it's going to go through and give you here's the speed when it happened, etc. So all good things. So that's all part of the generic side. Now, I also mentioned that you can go through and check it from the OBD2 the OEM side as well. So you want to add vehicle details to the OBD direct section. You can also add this. So since it's a generic vehicle, you can go in, you can hit yes, and it'll save a record. I'm just going to hit no because I don't really need it. I'm going to go into scanner, and it already has it loaded. So I'm going to go in here. And we'll see how long this takes. I may need to cycle it again. Okay, there's my vehicle, 2010 Town and Country with 3.8. And then on some vehicles also, it'll do fitted systems on the OEM side. So it'll just show what systems are fitted to it. So if I wanted to go into the engine, and you'll see I can go into codes, clear codes, data. This is, once again, the OEM side. If I wanted to go into generic functions, however, I can go in and it give me most of the generic stuff for the vehicle. Doesn't have mode 1. Doesn't have mode 10, and it has 4 mode 9s in this case. So it can vary from vehicle to vehicle once again. But if I wanted to go in there and wanted to look at freeze frame, I can still pop in there and do that. It's going to give me that freeze frame data. And it's kind of like a hole in that wall between the two rooms that I talked about, right? So that'll be in there. Also, another thing that we do is if you do a pre-scan on the vehicle or post-scan, in that case. Now, in this case, there's only a couple actual simulated ECUs in here, so we're going to get a lot of codes, battery voltage and stuff. And it's going to take a minute because it is, once again, a simulator board. Door module. You know, through 9, I think we're like halfway there. I just want to show you a couple things here as well before we wrap it up for the week. Almost there, 15. I think like 18 or 20, I don't remember. A lot of it's going to depend on bus speed on the vehicle too. There we go. Finished and saved. So what I wanted to show you is down here at the bottom. After it goes through all the modules on the car, it's also going to check mode 3. So OBD2 codes in mode 3. And also checks their permanent codes, mode 10, which we'll talk more about next week. Notice how there are 4 codes in OBD2 and there are no codes in the OEM side. And you may see that from time to time. I know GM has a thing with doing that. So you may see that. And oftentimes you need to clear the codes before they go over to permanent codes as well. Just so you're aware, sometimes you even need to do a key cycle before it trips over. Also checks the readiness monitors for you too. So it pulls in a lot of that generic data into the OEM side when we do that code scan as well. All right, so there's our first 4 modes and the history of our OBD2. Hopefully you picked up a few tips and tricks there that we can use, and hopefully you'll continue on next week to see what we have in store for that. As I said, next week is the second half of this class. So it's the Power of OBD2 Information Part 2. Now, I will say, just for those of you who want a live class, and want to know if it's a live class or it's pre-recorded, next week will be pre-recorded because I am going to our big tool show in where are we going this year? Nashville. So we got a big tool show that happens every August, and we're setting up for it next week. So I will be on the road. So it will be a pre-recorded show, but it still will be the same time, same place, 6 and 9 Eastern. If you want to join on Zoom, you can go to snapon.com/OT, register there, catch it on Zoom. 6 p.m. Eastern class is going live to YouTube. And then the 9 p.m. class goes live to my Facebook page, facebook.com/SnapOnJason. Give me a follow over there. Also on YouTube, youtube.com/SnapOnDiagnostics. Make sure you're subscribed, thumbs up. ring the bell, all those good things. If you want to see any of the past topics in this series, there's actually 67 different topics in here. Would have been topic 66. Anywhere from ADOS through our OBD2, our resets and relearns, maintenance functions, thermal imaging, a wealth of information, all about half hour, 40 minutes long or so, all available on our YouTube channel, youtube.com/Snap-on Diagnostics. And there's a playlist for live training available. All right, we'll get to Q&A in 1 second. Looks like you got a lot going on YouTube. If you are on Zoom and you join late and you do have a question, just look for that Q&A button on your Zoom screen. You should be able to type in a question there and I'll get to those. Also want to mention my buddy Keith. So Keith does new product training. So if you're a new user or you want to get schooled up or reschooled up on your tool that you're using, Wednesday is on Zeus Plus. Thursday is going to be up on Apollo and Triton tools. And they're both about an hour and a half or so long. First hour is going to be on, let's make sure everything's set up, Wi-Fi set up, and make sure we talk about Snap-on Cloud and the security link and all that. And then he'll talk about scanner functions, code to completion on intelligent diagnostics. Then the second half, after about a 5-minute break, he'll go through the guided component test, scope, meter, all those good things. Very thorough class. It is Zoom only just because it's designed to kind of have the tool in front of you. You can ask questions. We'll type questions to him and get your questions answered from one of our product experts. So definitely worth your time if you want think you want to learn a little bit more about the tool you already have, or maybe you're thinking about changing tools. You can see the differences there. So snapon.com/OT to register for that. All right, so good questions on Zoom. We are clear. We got quite a bit of chatter going on Zoom, which is always good. Audra Klima, hello from Europe. Hello, welcome. Thanks for joining us all the way over there. I know it's pretty late at night, so welcome. Quinn, welcome. Good evening. Matt Eberly says, I still have a graphing red brick from 03 and all Euro, Asian, and domestic from 80 to 2002. And I bet you if you put some batteries in it, it still works. And it works well. You just could not kill those things. That's why they call them a red brick, right? And yeah, there was a ton of cartridges back then too. It's crazy. Jorge, says, if there's no power, would it not be the fuse that powers the DLC? And of course, to shorten the wire, it could be. That's a possibility. If you don't have, or open in the wire, really. If you don't have power on pin 16, though, usually that circuit is shared with the ECM. So if there's no power there, there's going to be no power to the ECM, or the ECM is going to not communicate with you that way. So just be aware that if that happens, that's the first thing you need to fix before you go and diagnose anything else on the vehicle. H-Scope user says, good evening. Good evening. Welcome. Donald Hopkins said he had a 94 C220 that had both connectors. So he had the OBD2 connector and the 38-pin connector. It must be a Mercedes, right? C220. Only ever use the OBD2 side, however. Yeah, perfect. So that's kind of an early adopter in that case. You get those 94s, 95s. Sometimes they do have those 16 pins. Just kind of getting ready because they knew ahead of time. It's just 96 was the cutoff. Motorhead 1 asks, what do EV Teslas use? So Teslas, since they don't have emissions, Teslas have no emissions anything because it's a fully electric vehicle. It is a proprietary connector. They have a proprietary connector and they have their own proprietary software that they use for it as well. So it's a laptop version for that. There are some aftermarket tools. I think you can get limited data through it with it's a special adapter for it. It's not a OBD2 adapter because they don't have to conform to that because there's no emissions. So if it's a fully electric vehicle, it doesn't have it. Now, when it comes to like Fords and Chevys and Hyundais and whatever, who already have usually a gasoline version of their electric vehicle, a lot of times they just kind of take the motor out and put an electric motor in. Oftentimes they will still have an OBD2 connector because it's easier for their factory tool to still communicate with the BCM and the HVAC and the brakes and all that other stuff on the vehicle. So usually they will still have an OBD2 adapter on. Motorhead also says of CAT and Kando for heavy equipment trucks, only the dealership can scan the entire system. Maybe. It depends on the vehicle and depends on what kind of CAT motor you have, but I know the ProLink has excellent coverage on CAT, so maybe that might be something in an aftermarket world. Donald Hopkins says 93 Ford Crown Victoria using MT2500 as a troubleshooter function. That is some cool information. Yeah, we don't just have troubleshooter on the OBD2 side. We also have it on the manufacturer side, and it's more manufacturer specific on that side too. So if you go into engine troubleshooter, you can see some good stuff in there. Keith Bland says hello, welcome. Quinn says, are all these functions part of the scan tool and not part of the intelligent diagnostics feature? Correct. So it's just built into the scan tool. Any of our scan tools that are out there has that capability. And it's also not tied to the updates either. So it's generic OBD2. So no matter what, on any vehicle, as long as it's OBD2, you should still be able to scan it no matter what. Doesn't matter how out of date your software is. Now, like I said, there were some changes in OBD2. So maybe you might not, if it's really old software, you might not have the troubleshooter in there. You might not have mode 10 capabilities because that came out kind of like later on. So with that, Nick says, hello, welcome from UK. Thank you for joining us as you do every week. Matt Everly says Tesla uses a 4-pin connector and a scan tool, almost impossible to get. Yeah, like I said, factory software. Anthony Nofi says, thank you, Jason. You're welcome. Jorge says, thank you as well. Thank you for joining us. Harold Burton is watching. Thanks for joining us. Thanks for commenting. And let's see. Nick says, no communication with my Snap-on Zeus on Ford vehicles. What may I be doing wrong? I'm going to have to ask what year Ford vehicles, if they're modern Ford vehicles. If they're 18 and newer Ford vehicles, you need to have your Wi-Fi on. And you need to have your software up to date. So make sure that's a thing. Otherwise, if they're older Ford vehicles, it could be something. Could be something in the software. Could just be some coincidence with the Ford vehicle. Not sure. He may get to my answer there, but I know there's a delay between here and YouTube. So I'm going to give that a minute to kind of ponder that. Newer Ford vehicles, 18 and newer, they have security. 15, no, that shouldn't be too much of an issue. Of course, we're in UK too. Nick, I would call tech support over there. UK tech support over in Kings Lynn, and see if they know of anything over there. Because I don't have UK software, so I've played with it a little bit, and it works the same. It just covers different vehicles, but it's programmed over there. All right, so if there's an issue with it over there, they would know it over there. So that's the best thing I can tell you is call tech support over UK tech support, because San Jose is not going to know anything about either. So it's best I can do for you, Nick. I'm not sure 100% what that issue might be. It sounds like it might be just a software glitch. Just make sure everything's up to date. All right, with that, I think that covers it. And I'd like to say thank you very much for taking a little bit of time out of your day to take up a little bit of knowledge on OBD2. I know it's a hot topic. We did this last time. We got quite a few views on this. So hopefully you took away some good OBD2 knowledge. Hopefully you'll join me next week for the OBD2 part 2. And then in a couple weeks, we will be starting brand new classes as well. So we have a whole new slate of 5 classes we'll be talking about in a couple weeks, mid-August through. That'll bring us through almost October. So with that, enjoy the rest of your week. Enjoy your weekend. Have a good night and take care.